Okay, good evening once more, everybody, and welcome to today's session. Where in our today's session, we are going to be looking at a project. We are going to try to look at a holistic Kubernetes project in which we have a database that we are going to deploy, and that database we are going to deploy it along with its UI, that is its user interface. This is what we are going to have. We are going to have a database deployed. A database is going to be deployed there, and then the user interface for the database is going to be deployed there. We are going to have the user interface for the database deployed. Now, this database is going to be deployed as a deployment, which means we are going to deploy it with replica set, with the ports inside, and with replication controller. Everything is going to be deployed as a deployment, and its service is going to be there. You remember what we said about service. A pod or a deployment gives a service, gives a deployment the network to communicate, because this external UI, people have to pass through this UI to create tables in this database. Okay, because people have to pass through this UI to create tables in this database, it will be important to make sure that this database has a service that it can communicate with this UI. Okay, and this UI is going to also be deployed as a pod, and this UI is going to be made available to the outside of the internet. We are going to have access to this UI from outside. This is how we are going to do. We are going to have access to this UI from outside, but we cannot have access to the database from outside, because the database and the UI are blocked. The database is inside here communicating with the UI through a service. In our study of services, we studied two types of services. There is an internal service, which is called what? The cluster IP service. That is the service through which the database communicates with the user interface through the cluster IP service. This boundary like this is so that external network should not cross through this boundary and reach here. So this one and this one communicate through cluster IP. Then this one will communicate to the external world through the service called load balancer. Okay, so we are going to deploy this and its service plus its secret. You know that in order for this person to talk with this one, you need some secret, because it's a database. Of course, it's something that is secret to the company. It's something that is more important to the company, so it should have some login credentials. And then we are going to give those login credentials pass them as secrets here, and then we are going to also give the credentials to this one as secrets. Okay, so the next thing we are going to do is we are going to set all these things in such a way that this very user interface can be able to, we can change it so that it can attach to several databases. We should not only make it be able to attach to one database, we should make it to be able to attach to different databases. And with that, we are going to bring in another object of Kubernetes, which we call configmap. So configmap is a configuration layer which we are going to also orchestrate here, such that if we want this user interface to communicate but with a different database, we do not have to come into this to the manifest file of this UI to change all those things. We just come but to the config map. So the config map will be some sort of a layer that will keep up here, where we are going to take the configurations of this one, and instead of hard coding it here, we are going to take the configurations and code it here. The configuration for this person to attach to this person, we are going to take those configurations and code it here. Such that if we want now that a different person to attach to this one, we change the configuration just from up here, not from inside here. That is the use of a config map. So in all and all, we are going to have what? The various different components that we are going to have in action are: number one, we are going to have a deployment. Number two, that's a deployment for database. We are going to have a service for database. Then we are going to have deployment for the user interface, which in this case we are going to use Mong-Epress, and we are going to have service for user interface, and then we are going to have secret for database, and then we are going to have lastly config map. We are going to have lastly config map for all these settings. So we are going to have in total 6 different configurations of YAML just to set up our Kubernetes project. 6 different configurations of YAML. All right, I saved the time and I prepared the configurations for you here. So here are the configurations. We have the first one is this one. This is a MongoDB configuration, the MongoDB manifest file. We are keeping things simple, replicas as one. The name is MongoDB. The app is MongoDB. That's the app name, the port name MongoDB. We have the match labels here. through this particular label, our service is going to be matching to our port. Now we have the container. This is the container which we are going to be running. That's the name that we are going to give to that container. And then the image which we are going to pull from Docker Hub is called Mongo. The image that is going to be pulled from the Docker Hub is called Mongo. What is this configuration all about? What is it going to do? It is the database configuration. Okay, then we are going to be exposing the port on 27017. This one comes officially with the image. This port like this is a port that comes with the image. We are not the ones that decide this port. It comes with the image. Now what we are going to do here is that we have to create a username for our database. We need to create a username for this database. And in order to create a username for this database, we are not going to write the username in plain figures. So we are going to pass the username through the secret. This is what we call secret. We create a username. That means we are telling this MongoDB that you are going to have a username, right? But that username is going to come from somewhere. It's going to come from a secret that we are going to pass, right? And in that secret, what are we going to be passing? We are going to be passing the Mongo root username. We'll see the configuration of the secret. And we are going to pass the username and the password. Where will that password come from? The password is going to come from the MongoDB secret YAML file, and the value is going to be Mongo root password. Okay, this one was Mongo root username. This one is Mongo root password. So come along here and look at the secret. Here is the secret. In the secret, we are saying that the name, this Mongo deployment will recognize this secret from this particular name, MongoDB secret, right? This MongoDB secret, if you come here, you will see the same name is here, MongoDB secret. So that is the reference. That is how the deployment is going to make sure that it is communicating with this secret. And then these are the values that you need to pass. For the type, this is an official type which is opaque. So these are the values that you need to pass. Now these values like this they are already coded. I'm going to show you how to code this value. This value like this is username. Okay, it is username, and this value is password. But we do not write username or password. No, you write username and then you encrypt it. When you encrypt it, then you pass it now as an encrypted value. I am going to show you how to encrypt a plain text to come out into this jargon that you are seeing. Because if somebody steals this our secret, what is he going to see? He's going to see but this jargon. No matter what you do, you are not going to be able to decrypt what is written here. You are just going to see but this jargon. Okay, but actually what I wrote is username, and what I've written down here is password. I want to keep things simple. I just wrote username and password, and then I encrypted it. When I encrypted it, it gave me this jargon here and this jargon here. Okay, so if somebody steals this secret, he's going to see this, but he can never decode this. Only the computers know how they encode and decode. They call it base 64 encryption. Okay, you can do that with your plain Linux. Okay, so I will show you how that is being done. So let's go ahead. So for simplicity's sake, this is your secret that has already been prepared. This secret is meant for this deployment. Now we said every deployment has a service, so it is normal practice to put the deployment and the service together. Look at something. This is the deployment, this is its service. So this deployment like this is exposing 27017. Here is its service down here. When you want to put the deployment and the service together, you separate them with 3 lines, 1 2 3, and then you start writing service down. So this service is exposing the port 27017, that is its target port. The service says that okay, the port you are having 27017. I am going to take that you are 27017, and me, the service, I am going to also now send out 27017. You can change it. Okay, you can take the port from here and change it to a different port number here, so that the service should send but a different port number. The basic ideology is that what the deployment cannot actually communicate to the external world. The deployment itself cannot communicate like here. This deployment cannot communicate to the external world. It needs a service to communicate to the external world. So the service can take the same port number that the deployment is having to communicate with the external world with it. So that's why we are having this here. That's why we are having this here. It is taking the port of the deployment and still sending out the port of the deployment. Okay, now at the level of the Mong-Epress, here is the Mong-Epress. What happens at the level of the Mong-Epress? We have said the Mong-Epress communicate directly with the database. So this Mong-Epress should have something common with the database. And what is that thing that is common with the Mong-Epress and the database? It should be, first of all, the username and the password. So the Mong-Epress is going to take the values the same from the secret, right? It is going to take both the username from the secret, and it is also going to take the password from the secret. You see, it is all saying that Mongo root password, referencing what? MongoDB secret. This is the reference. The Mong-Epress is going to take all these figures and then refer to the secret. So the database and the Mong-Epress are using the secret. If we can try to sketch something here. Okay, we have a secret that is kept. Generally, these secrets are always kept in vaults. Okay, we have a secret that is kept up here. Then the Mongo-Epress uses this secret to authenticate to what? To authenticate to the database, right? So this Mongo-Epress uses this secret to authenticate to the database. So what the Mongo-Epress and the database have in common is the secrets. All right. Now we go ahead. At the end of it, we have a config map. What happens at the level of a config map? At the level of a config map, we are saying that we are going to be giving the database a URL. We are going to be giving this database a URL. And this URL, we are going to pass the URL only inside the config map, right? If you see, these are values from the config map. We are going to be passing this URL inside the config map. We just tell this this Mongo-Epress that there is a config map existing, and the URL of that database is going to be put in that config map. Now, why is this config map coming into place? Config map is coming into place because at one particular moment we can decide that this Mongo-Epress should not communicate but with the database. We change the database. When we change the database, we just need to come to the config map and change the config map. We don't need to come directly inside the ports and start changing things inside the ports. No, we just come to the config map and change the config map. Okay, so the Mongo-Epress is also having its own service. Now the service of the Mongo-Epress is having a type. Take note, the service of the database was not having a type. Why is it not having a type? It is not having a type because if you don't put a type, Kubernetes knows that the default type is cluster IP, which means internal communication. So the service of the MongoDB is not having a type. Now the service of the Mongo-Epress is having a type, and the type is of type load balancer. Okay, this load balancer now is going to make sure that traffic is sent out to the internet, and it will be communicating through port 8081. All right, so the node port that is going to be making that accessible is 3000. So I hope you understand these three. I think I explained these three different ports. We have the target port, we have the port, and then we have the node port. What is the difference between the target port, the port, and the node port? There are differences for all of them. Right? The node port is the port that is carrying the Kubernetes setup. Is the port of the instance that is carrying the Kubernetes setup, right? The target port is the port from where the traffic is coming from. That is, technically it is always the port of the container, right? The port from where the traffic is coming from is the target port, and the port itself now is the port where the service is actually releasing. So how does traffic flow? Traffic flows from the target port. When the traffic is coming out, consider traffic coming out from the system. Then the traffic will leave the target port, right, enter the port, and then pass out through node port. Then consider traffic going into the system. The traffic passes through the node port, right, enter the port, and then come out through the target port, and then passes through the target port to enter into the final system. Now, but minikube has its own way of doing things. You know, minikube is set up inside an instance. So this node port that we are calling node port, that means it is the port of the node that is carrying the minikube. But which node are we talking about? Is it the physical EC2 instance that we are going to set up? Of course, no. It is not the physical EC2 instance that we are going to set up. This node port is the node port of the node that was created in minikube. You know, when you launch minikube, there is a mini computer that is created inside your computer. That is the node that we are referring here to as node. So we will reach a level where we are going to be forwarding this traffic from this node pod to our EC2 instance itself. And I am very certain that that is why Mr. Kiba could not be able to access his service, because he is running a minikube, and minikube is inside a pod, inside a node, and that node is inside his computer. So the traffic has to come out from that node before coming out into the I think you are using the WSL, the Windows Linux system for Windows. So the traffic has to come out from the node before coming out from that WSL, before coming out into your physical computer. So there is a level of port forwarding that you need to do before you are able to access your traffic. So this is the general thing here. Before we go into actually implementing it, is there any question so far? Yes, Mr. Kiba.
Yes, I'm not really clear about port and target ports. Is a target port the port of the node? That is, we understand that the port is POD and PUT. So I'm a little bit confused there, sir.
Okay, you are confused about port and ports.
Yes, sir. Target port and the port.
Now, let us come here. This is where you are referring us to?
Yes, sir. Yes, sir.
You are confused about the target port and the port.
Yes, sir. This target port, is it the port of the node?
No.
That
this is the port. This target port is the port of
the port, the POD.
Yeah, it is the port of the container that will be running inside the port, inside the POD. No, there is in every port there is a container running inside.
Yes, sir.
So the target port is the port of that container that should be running inside. Okay?
Okay, sir.
That's the target port. So now the information leaves that target port and then comes to the port of the service now. Right?
Okay.
And then leaves the port of the service and comes down to the node port where we are able to access it.
Okay, sir.
Yes. Now, and then you will discover that we have two services. So in all the services, you will find out that here, when we are talking about the Mongo service, here you are seeing port 2707 and you are seeing this one. So the target port is the port where the actual container is running, and then the port is now the port where the service is running. You see the two difference?
Okay, sir.
Yeah. So this one takes information from inside here and then it passes to this other service here. Okay?
Okay.
All right. Any other question? Okay, let us set up our cluster. I'm sorry I could not set up the cluster as early as possible. I had to come back very late. DB minikube. Yes, Declan.
Okay, so excuse me. I saw somewhere that IP addresses are also used to encrypt and decrypt sensitive messages.
Now IP addresses are used to do what?
that an IP address like public IP
Yes.
can be used to encrypt a sensitive message, and as well can be used to private IP can be used to decrypt those same messages.
Which type of messages?
That's what I'm still trying to understand, sir.
When yeah, the way you place your question is a bit it's a bit confusing, because when you say messages, we are now in IT. You should not be talking again like somebody who is still a newbie. In IT now, you refer to the particular network which you are talking about. What do you mean by messages?
And it's that as of sensitive information.
Are you talking about the flow of network, or when you say in messages, are you talking about data?
Data, sir.
That IP can be used to encrypt data,
That's what I'm trying to understand, sir.
and you think with your own, just consider yourself a very newbie in IT. How do you think you are going to use IP address to encrypt data?
That's why I wanted to find out, sir, if that's possible.
Um, generally in IT, you can never know what somebody is doing in one part of the world. But the best of my knowledge, I haven't come across the usage of IP addresses to decode or encode or encrypt messages. I haven't come across.
Okay, sir.
But it doesn't mean that it cannot exist. But to the general logic, it is out of place to think about that type of a thing. Technically, it is out of place. But as I keep saying, when it concerns IT, you cannot stand anywhere and beat your chest that this thing can never happen. Because when we started learning Terraform, it was said that when you lost your state file, you can never find it. Somebody just challenged us the other day that he can recreate the state file, and he did it. And I mean, it was like magic to me. So don't just hear things and then go start running your mouth that it cannot be. Always be modest and show some level of logic that you understand yourself.
Okay, sir.
Okay, let us install the almighty minikube that has been torturing the clan. I don't know for what I don't
Get with me.
I don't know for what reason this thing
Get
was
with
dealing with you.
There was my Hyper-V was off.
It was what?
Hyper-V.
Let me try something here and show you something. I'm going to install it in series of commands. I bet this thing is too small and you cannot see, but nobody is complaining. If Adija was there, Adija could have complained.
Because we know what you are doing already, sir.
Okay. That's great. Okay. Why does my script keep disappearing? Yes, Mr. Kiba.
Okay, sir. I don't know if I would interrupt you while you're installing this minikube. During the session, you said configmap is used to configure external configuration for our URL, that is with relative to our database. In case we change our database, we shouldn't go to that database now, sir. But this is simply is one straight manifest file. Why can't we just scroll down and change the name of the database? Or it's not like I'm thinking.
Now, you are talking about one manifest file, right?
Yeah, I see. You made just one manifest file and everything is there. The secret, the service, the database, and yeah, and the config map.
Okay.
So you said in case, yeah,
In the case where you have 1,000 ports,
uh,
will you manually go
I get
and
it. Oh, no.
change all those
Okay,
things?
okay, okay. No, you cannot go there, sir.
That is to be
Yeah.
done when because we are just doing this at a very small scale by putting
Okay, okay.
one node
One
and,
database.
and and one database and the rest. Because in a real world you are not going to have one. You
Okay,
are
sir.
going to have so many of them.
Mhm.
So you don't
Yeah.
have to be going port by port, reconfiguring the ports to point to a different database.
But
You
from the config map, it will be like automatic to all
Yeah,
the data.
you change one config map and everything changes.
Okay, sir. Okay,
Everything changes. So
okay,
that is actually the use of config map.
okay. So well noted.
And you will also see a lot of as you'll be going ahead, you meet so many different Kubernetes objects. As I said, we have not even done half of them. There are many of them that are existing. What happened? the client could not install snap.
So that is the command that was that made me to run mad. I went to Obilio. I paid for time. Start on the cyber. Kunobo, I changed the cyber. I went to another cyber. Start there for 2 to 3 hours.
And
I
you become a
changed
demon.
all the networks. Hey, it was like the next demo was also after me.
The demon of Mr. Rene.
Mr. Rene, yes. I changed. I worked from cyber to cyber. I could not go. It was the other down, and I said, okay, what is wrong? I went and I discovered that was my Hyper-V. Hyper-V was switched off. I don't know who did that.
Your Hyper-V was switch off.
It was off.
That's dangerous.
Oh my god!
Yeah.
And when I activated my Hyper-V and I relaunched everything, it worked.
Some
And I
of
was activating data twice a day.
some of those things, these things like this, you really need to understand exactly what is happening. Otherwise, you can go mad without actually
Tell it
knowing.
yourself. I swear.
So I almost went mad. Oh. I will activate the bundle of the day and the night at the same time, and it will not go for 1 week. It was even more than 1 week. I'll activate all the networks I have and the night bundle. Could not go. I took my bag. I went to a cyber. I sat there. And I bought time, thinking that the network will be fast and will help me.
Well, when it happens like that, you master certain things very much. I think I have mastered Jenkins to a certain level today that I can really do Jenkins pipeline without looking from anywhere because of the way the thing actually, the steep of learning actually disturbed me when I was studying. I will build pipelines. I think that is when AWS blocked so many of my accounts because I will build pipelines like the whole day and none of them will ever run successfully. I mean, I will spend 3 good days sitting without going outside, and you would think that
Wow.
I'm working something very, very important when I am not able to build one pipeline.
Wow.
Jenkins.
So you understand that with that I learned as many different techniques on succeeding in my pipeline. The first day my pipeline ran successfully and installed and published, deployed in the test, the QA, and the production directly and was available. It was like magic to me. So I understand how some of those things really frustrate.
No, so I was frustrated to the highest level. I almost went mad.
All right. Okay. We have our Kubernetes installed, so we start running our commands. How do we run our commands? We have how many files that we need to run the commands? We have 6 files. In which order do we run this command? The very first command that we have to run is a secret. This is a secret because the database needs information from the secret, and the Mongo-Epress also need information from the secret. So the first thing is secret has to be put in place. When secret is put in place, database is put in place, database service is put in place. Okay.
Okay.
So let us execute secret. Yes, Ms. Akiba.
No, sorry, it's a mistake.
Okay, we create the YAML file. The YAML file will be called Mongo. This is it, Mongo secret.yaml. Let's create it. That's a file. So we copy the configuration in secrets and we paste in our file that we just created. Now we execute. Mongo secret dot YAML. I think our syntax is okay. Our file has been created. The next file that we are going to create, our port has been created. The next object that we are going to be creating is the MongoDB the deployment and its service. We are going to create both the deployment and its service at the same time. So let's create a mongo.yaml folder file, please. There we copy all this. There we paste. There we save and quit. And then we launch. Our deployment and our service is created in one file. The next thing now that we are going to create is the config map. Look at what we are having here. We have created the secret, we have created the deployment here and its service. So we first of all have to create a config map before you create the MongoEpress and its own service. So let's create the config map. Let's first of all create what is the name that we are going to give to it? Mongo config map. Here is the config map. Mongo config map. There we copy it. We save and quit. We run it. Created. Now we create the MongoEpress and its service. This is it. MongoEpress with its service. So the name is mongoexpress.yaml. We copy everything here. Then we execute. All right, everything is created now. Let's see what we have just created. kubectl get all. What did I write?
You forgot E. Okay.
So this is everything that we have created. You see, we created two deployments, right? The deployment for the database and the deployment for the Mongo-Express. And then we created two services, the service for the database and the service for Mongo-Express, right? And if you look at it very keenly, you discover that all the services are cluster IPs. Only one service is a load balancer, okay? And it is that service that is a load balancer that is going to give traffic out, okay? Then we have our deployments are ready. Everything is ready. We have up to date 1, ready 1, available 1, okay? This is a replica set that we are created. We have two replica sets. Remember that a replica set is a subset of a deployment. So wherever there is a deployment, there must be a replica set, okay? So everything is functional. We are good to go. Question: we have created this beautiful thing now like this. How can we access it? That is the right question. How should we access it? Now, the first thing to do in order to access this is to draw this structure so that you see what is actually happening. Because if you don't get the picture of what is happening, you will be struggling to access something that is not accessible. Now, look at what we are going to have here. This is our computer down here. This is our computer down here. This is our laptop. Now, this is the cloud, and this is the computer in the cloud. This is a computer in the cloud. In this computer in the cloud, we have set up a minikube with one node. That means we have set up another computer inside this computer in the cloud. We have set up a system with one node inside this computer in the cloud. Now, when we talk about this node port, because when you see there is a question that I would have been expecting somebody to ask, but I just want to explain it before anybody ever asks. When you configure this, and we are talking here about node port, like Mr. Kiba asked, here is our Mongo-Express. Under normal circumstances, we are finished, right? We are finished storing everything. We should then take, we are saying that this is our node port. That means we should just take the IP of our instance and add this port to it, and we will see our application. Also, that means this is what we are expecting. We just come here, we take this IP, we take this public IP here, and then we put in our web browsers. And then we put the port 3000. Is it 30,000? This is what we are expected to have to be doing. Since we explained that this is the node port, and the node port is a port that is opening to the computer that is hosting your application. But in the case of minikube, look at what is happening. That node port that we are talking about is neither the node port of this physical computer, but it is a node port of the mini computer that is inside this physical computer. So that node port will be the one here. So you have to first of all forward that node port from this computer to this other computer out to this other port outside here. So there will be a port forwarding from this minikube node to the host node. The node where minikube is installed is called the host node. So you forward the port from the minikube node to the host node, and then you open what we call the minikube tunnel. If you don't open the minikube tunnel, there will never be an accessibility from here to here. So you have to open a minikube tunnel. And in order to open a minikube tunnel is a tunnel that you open and it remains running in the background, which means you have to open it in a different window. So if we want to open a minikube tunnel, we have to come to a different window before we open that tunnel. We open another window. This is the second window that we are going to be using, and in this window we are going to open the minikube tunnel. In order to open minikube tunnel, just write minikube tunnel, if I'm not mistaken. Okay, you see our tunnel is running. It is telling us minikube, no errors, router, no errors, load balancer, emulator, no errors. There is no error that is we are having so far. Okay, now we have opened the tunnel. The tunnel is open. We keep it. We come now to our main environment, and then we say we have to forward now the traffic from the inside port to the inside, from the inside node port to the outside node port. So we have to run the command minikube port forward minikube port forward. Right now, when we say port forward, we say we are forwarding from where? From a service. We are forwarding from a service. And what is the service name? The service name is MongoExpress service. Right, this is the service name, MongoExpress service. Okay, we are forwarding to where? We have taken like this. We are forwarding from MongoExpress service. Now we are forwarding to a different port. Let us forward to the port 3333, right? And then we map it to 8081. Okay, now we are adding an address, hyphen address, which is from where? From the internet, 0.0.0.0, and then we want it to be running in the background. Let me verify this command so that we make sure that we all are in the right track. So this is the command, kubectl forward that to that to that. Okay, I got it. So instead of minikube, we have kubectl. I think we got it right. Hyphen address that. So let us changed it from minikube to kubectl. kubectl port forward service Mongo-Epress service. Is this how this service is written? Mongo-Epress service, yes, hyphen that, yeah, hyphen this Mongo-Epress service 33 hyphen address that. Okay, our command is good. Let us fire it up. Okay, we can now see that forwarding from the internet through 3333 to 8081. Now 8081 is the port of the minikube, then 3333 is the port of our EC2 instance. So right now we can be able to access our application from this port 3333. So what do? We take the IP address of our instance, and then we put 3333. Now we are being asked this username and password. Where can you get this username and password when it concerns MongoDB and Mong-Epress? The username and password is going to come from if you go to the Docker hub where Mong-Epress is actually found. Let us visit the Docker hub and see something there. Are we in the Docker hub? I think I tried to access Docker somewhere here. Alright, if you go to the Docker hub, you will see that minikube actually that is MongoDB actually is in need of an authentication, and the authentication is under username. You have you are supposed to write, I think it is admin, and then under password it is pass. Let us actually confirm that by going to Docker hub. This is Helm. Where is my Docker hub? Oh, here it is. Okay, this is the document for that I prepared your project with it. This is Mongo-Epress, and the Mongo-Epress, when I checked the document, I discovered that there is a login credential somewhere here. You see there is something like the username will be admin, and then the password will be pass. So they say the following are only needed if this is considered false. So in it was configured and put false. So we have to put admin and pass for username and password. So here you put admin and pass, and then you sign in. Et voila. So you have your user interface right now. This is your Mongo-Epress. Your database is running, and from there you can be able, from this Mongo-Epress, you can be able to create your database, right? You can create databases from here. I can create a database directly from here. Like create a database. I can give my database name and everything. So database name, I say test database, create. So this is a database I just created, so I can enter there and add my fields or add my whatsoever, view, export, delete, import data into it. So I'm using this user interface to be able to access my database. Okay, and the database credentials are found in the secret that we configured. So this is already a whole system that has been built for you. In the real world, this will be the application that is running your service, like a web based application, and then the database will be behind. Nobody will be able to see the database. So this application now will be accessing the database and creating writing data behind in the database. You have successfully set up a Kubernetes 3-stage architecture. So is there any question? Nobody has a question? Okay, if nobody has a question, then I have one for you. I have one question for you. My question is, why should we need to forward an IP or a port when we already have load balancer as an external service? Declan, are you answering my question or you are asking your own? Yes, Declan.
Okay, sir. Because of the fact that the class was except watching the video again, I can put this question clearer. There was a password and username that we created. I think was for the Mong-Epress, I think.
Yeah.
Where you said there that the password is such encrypted in a way. I did not actually see where it was used. Oh, that was my worry.
Where it was used?
Yes, if need be.
You did not see where the password was used or where it was created?
Or where to use. Or where, like for example, so
did you not
where
see
you need to use the password?
Did you not see that is the very first thing that we launched? We started by launching what?
Was on and off.
We started by launching what? We started by launching the Mongo secret, right? And why did we start by launching the Mongo secret? We started by launching the Mongo secret because if we do not launch the Mongo secret first and we launch the database, this database will not launch because the database will ask you that it needs authentication.
Okay, sir.
Right? The database has been configured and told that, listen, you are going to need a username. So the database is being launched knowing that there is a username somewhere. So when they launch the database, it starts searching for its username. And when it starts searching for its username, it goes and sees it in the secret that was already launched. So if you start by first of all launching the Mongo database, it will give you throw you an error because it will not see this secret.
Okay.
You get the point.
Yes, sir.
So we started from secret, then we went to database, then we went to service, then we went to configmap, then we went to Mong-Epress and its own service.
Okay, sir. Understood.
Great. So that is our project for today. I believe this project opens your mind for you to really understand how all these things are used together. Okay, do the project over and over and learn the I'm going to send you all the YAML files. Learn the YAML files very well, study them very well. If somebody destroys them, can you rebuild all of them together? Study them from that angle, okay, that if you are told to rebuild these YAML files, can you rebuild them? Or if you are given a catalog of a YAML that is not up to this state, because you will never see a YAML file that is like this, that is exactly like this one. It will be difficult. You will see a YAML file that this part like this this part is not there, okay. You will just see a YAML file with container port and it ends here. So you are the one now to say that no, my own YAML file, I need environmental variables. Then you are going to add this part now, and your environmental variables are what? They are the parts that are going to be taken from your secret. How are you going to write those parts? This is how you pass the parts, okay. So learn anyway. You always they will always give you most of these things. So the main important thing for you is to know how they communicate together. And as Declan already did a lot of research and went further to talk about Helm, see, we have taken a whole session of class today to show you how to launch one YAML file after the other, What if I tell you that we could launch all these YAML files in one command? I mean, is that not wonderful? To pack all these YAML files and launch them in one command. Is that not wonderful? So that is the power of Helm. Okay, with Helm now, we are going to gather all these YAML files and classify them into a chart, and then we add the repo of that chart, and then we launch one command, and all these things will be launched at the same time. Okay, so but I will, since Declan has already started, I would really like that all of you should do research on Helm. It is not part of our training, but it is a nice thing to know. You guys should do research on Helm. Okay,
Sure, sir. Okay, sir.
yeah. So we are going to continue. Probably, I don't know, tomorrow I will give information some few hours before, and we are going to look for a project where we are going to use secrets, whether ingress, and then I'm going to tell you the difference between ingress and services, how ingress and services function together, if they actually do function together. Okay, it's good you know how ingress and services function together. When we have done that project, and then we do I think that is the main project that we need to do now, for you to know now how to launch a whole application in Kubernetes. I believe if you already at that level, you know how to launch a whole project in Kubernetes, then we are good to go. I think the basics have been, the playground now is good for you. You can start sailing into the sea, searching, adding more knowledge into what you already know. I told you about RBAC. Try to know more about RBAC. Try to know more about namespaces. How are they used? We have used secrets now. At least you have seen how secrets are used. We have used configmap. You know what configmap is all about. So you can tell somebody, if they ask you what is configmap, you can tell somebody what configmap is all about. If they ask you about ingress, you can be able to tell somebody what ingress is all about. And then if they ask you to describe an application, which the owner of the application wants that there should be a part that is communicating to the external internet and another part that is not communicating to the external internet. What are the different Kubernetes objects that you are going to use? You know, the person is actually asking you to explain to him about node cluster IP service and load balancer IP service. Okay, some people will ask you the difference between ingress and load balancer service. How do they differ from each other? How does ingress differ from load balancer? Because ingress seemingly also works from outside, and load balancer seemingly also works from outside. So how does ingress differ from load balancer? Those are things to start igniting your head. Start thinking, start reflecting, start asking Google, start asking YouTube, all those type of things. You will be discovering more and more things, okay, that can help you explain a lot of all these things. Is for you to be able to convince the the interviewer that you know what you are doing. The part of actual practice, you will learn it in the job site. All this is just to convince the interviewer that you know how Kubernetes work. Actually doing it, you will learn it you will learn and get more knowledge in the job site. Okay, so our idea is convince the interviewer with a lot of conviction that you know what you are saying. So in order to do that, you have to practice all these things. When you practice them, you'll be talking from your practice. You will not be talking from they told me that they told. No, I have done it, I have seen it, this is how I do it. Okay, when you talk from that angle, you are powerful rather than talking from what you read. If you read something, try doing it. When you do it and it fails, you will finally get it. And when you get it, you will best explain it to the interviewer more than anything. All right, so we'll do one more project with Kubernetes and we wrap up Kubernetes, and then we go back to we cross to Ansible. Okay, and before we cross to Ansible, no, we take Ansible and finish Ansible before we come back to solution architect. Okay,
Okay, sir.
so great. You guys continue studying and continue practicing. We meet tomorrow, hopefully. Okay, see you all.
All right. Good night.
Good night, everybody.